Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N2. So in this platform we shall be actually focusing on trigonometry, which is a continuation from the previous classes that we had on trigonometry. So we shall see the relationship. As we can see here, we've got the relationship between the trig ratios. So we want to see what is that relationship that we have between the trig ratios. All right, so guys, if you're new, you can consider subscribing so that you won't miss any of the classes that we shall be having from Mason African Motives. So quickly rushing through this part, guys, I want us to note something here. We talked about quadrants, in fact, from our last class, where we had something like this. I just want to have a recap of that part. Sorry, that's 0 degrees there, and we've got 90 degrees, 180 degrees, 270 degrees. Then back to this point, we are going to be at 360. So take note how you indicate your angles, or how you take your angles. We are taking our angles in this direction, which is the anti-clockwise. I talked about this in our previous class, that any angles which are taken in an anti-clockwise are referred to as positive angles. Any angles that you take in the clockwise direction, which is the normal way a clock moves, which is the clockwise, sorry, let me just try adjust this side. All right, which is the clockwise in this case, they are going to be referred to as negative angles. So what does this mean now? It means if we are to write in terms of negative angles, the concept is going to be like this. We want to write this in terms of negative angles. So it will be like this. All right. 0 can never be positive or negative. It's just a 0 degrees. So it's a neutral number, that one. Plus or minus 0 degrees is just 0 degrees. All right. So now if we are referring to negative angles, that means we are going to be going this direction now. So this is going to be at 0, and this one will be minus 90 degrees, because we're talking of negative angles. So this will be minus 90 degrees, minus 180 degrees, minus 270 degrees, minus 360 degrees. So these are negative angles. So which means if someone is representing, and also take note about the quadrants, guys. I told you that this is the first quadrant. Remember that we've got the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So that is the same thing that we are having in this case. Still, this is your first, this is your second, this is your third, this is your fourth. But now if you are to see that in each quadrant that you have, you're going to indicate in terms of the acute angle. Each and every quadrant, remember I talked about this, that each and every quadrant is going to have a right angle triangle, which is drawn like this, where this is your theta, or it can be x. This is just an angle like that. Each and every quadrant is going to be having something like this. Each and every, so which means it's the same thing here. Each and every quadrant is going to have the same thing, just like this. 90, 90 there. This is your theta, your theta. So these angles will be at 90 degrees. These ones will be at 90 degrees. So as you can see, each and every quadrant is going to have a right angle triangle. And the other thing that is important is to know that in between this quadrant, you're talking about angles which are ranging from 0 to 90 degrees. So they can be written like this: 0 to 90 degrees, which are the values of x. Or they can be written, maybe your x is, in this case, can be written as x is greater than or equal to 0, like this, less than or equal to 90 degrees. That is in the first quadrant. In the second quadrant, that is of 90 up to 180 degrees. These are the angles that we are going to have in the second quadrant, which means we are talking about the values of x ranging from 90 degrees up to 180 degrees. The same thing, this quadrant is going to be from 180 to 270. So this one will be 180 up to 270 degrees like that, which means your x is going to be greater than or equal to 180, less than or equal to 270 degrees. The same in this quadrant is from 270 up to 360. So you can write it like this: 270 up to 360 degrees. These are the values of x that you're talking about, or your x is greater than or equal to 270 degrees, but less than or equal to 360 degrees. So each and every quadrant is going to have a condition like this. So given a condition now like this, how can we apply this information? Okay, this is how they ask these questions, and I want you to be very, very careful about this information, guys. You will be given a certain identity, or let's just say a trig. Let's not complicate things. Let's just put it this way: a trig. Maybe we are given that sine theta is equal to -3/5. This is what you're given for the theta. Sine theta is whatever, or they can write it as sine x. So take note, it can be sine theta, it can be sine x. Then they will give you the condition of that x that is greater than or equal to 90. Let's just say 180, guys. Let's not know. And less than or equal to 270, like this. This is the question. Or like I said, this can be x or it can be theta. So they can put it as theta, or they can put it as what? As x. So this is what we are given. All right. Then we want to calculate, or we want to find these trig. Cos theta, tan theta, sec theta. All right, then let's just say cos, let's just put it a d like this, like cos theta minus cosec theta, like that. So these can be the questions that they can ask you. So how do you answer such type of a question? But this is the part that we want to focus on. All right, this is how you analyze your question, or how you determine the values of the trig, because you are giving this without using a calculator. All right. What you're going to do is that from this part that you're given, you are given a ratio of a sine. This is a ratio of a sine, which you know that a ratio of sine from your SOHCAHTOA, remember, from your SOHCAHTOA, guys, you know that your sine theta or your sine x is equivalent opposite over the hypotenuse. So that means the sine that we are given here as sine theta, which is equal to -3/5, like this, represents the opposite over the hypotenuse. All right. And we are given an interval. In this case, this is the interval that we are given from 180 up to 270, which means which quadrant are we talking about? Let's go back here. We are referring a quadrant of 180 to 270, which means we are talking about the third quadrant, 180 to 270, which means your triangle is going to be like this in the third quadrant. If it was in the fourth quadrant, your triangle is going to be like this. In the third quadrant, like this. In the second quadrant, like this. So this time it's in the third quadrant. So our triangle is going to be taken like that. So this is how your triangle is going to look like. You're just going to sketch a triangle like this. All right. So as we saw that the triangle, take note, it's always taken from the horizontal and back to the center here at the origin. So from the horizontal, you draw a vertical line to the center. So this is your triangle like this. All right. So this is our 90 and this is our theta. So this is in the third quadrant. So once your theta is there, it's now easier now to substitute this information, because we said sine theta is equal to opposite over the hypotenuse. So according to this theta, this is your opposite. So this is your -3. And this is the hypotenuse, the one that is opposite to to 90 degrees. This one that faces 90 degrees, that's your hypotenuse, which is 5. So you used the trig ratio that was given to fill in the triangle. But as we can see, a triangle is supposed to be having 3 sides, complete sides. But here we are just having 2 sides. We are supposed to calculate the missing side, and we do not know this value. So where are we going to find this value of x? All right, we are now back to our Pythagoras theorem. Why? We are working with the right angle triangle here, and you have got 2 sides. You want to calculate the third side, so definitely I can apply my Pythagoras theorem, which states that c squared is equal to a squared plus b squared, given that your triangle looks like this. You only apply this when your triangle looks like this. This is your c, this is your a, this is your b. So as you can see, c represents the hypotenuse, a and b, these are the shorter sides. All right, so in this case, this is your c, this one. So we can just say this is your a, this is your b, and this is your c. The c is the hypotenuse, which is 5. So you're going to have 5 squared is equal to a and b. These are the shorter sides, so you can just substitute -3 on any of these 2. All right, so you can just substitute here -3 squared plus b squared, which is the x that we want to calculate. So you can just write this as x squared, or you can just write it as b squared, still is fine. So we want to calculate the value of that x. Okay, let's play our mathematics skills, guys. 5 squared, that's your 25, is equal to -3 squared. Take note, guys, a negative and a negative gives you a positive, so it's going to be 9, not -9. So -3 squared, take note, minus and minus going to give you a positive. Then you transpose, it's going to be a negative, so you're going to be left with 25 minus 9, which is going to give us what? A 16. So you're going to obtain 16 in this case. So 16 is equal to x squared. Remember, guys, how do you remove a square? This part here, because sorry, you're given a square there. How do you remove a square? You introduce the square root both sides. So you're going to introduce square root both sides. So that means your x is going to be square root of any number is plus or minus. So you're going to have our x being plus or minus 4. So due to the triangle that we have and the quadrant that it lies, as you can see, this is on this side here. From the origin going to the right, these are positive values. From the origin going to the left, these are negative values in the horizontal line. If you are in this vertical line, going up like this, that's positive. Going down, that's negative. That's why you see this one is -3. It's because it's in the vertical, which is downwards. So which means this side here, we are going to have a negative value of x, which is in the horizontal. So that means from these 2 possible values that we had, we are going to take a minus, because it is the one that is on the side. If the triangle was in this quadrant like this, let's say your triangle was in this quadrant like this, it was going to be a positive 4. Why? It's on this side. It's on the right side, which is a positive. So this one is on the left side, so that's -4, like that. All right. So we have completed our triangle using Pythagoras theorem. All right. Now we can answer the questions which were being asked there. All right. So let's see what we have from this triangle. Let's just put it this way. All right, so back to the question. This is what we had here. The question is calculate cos theta. All right, so let's find the value of cos theta. All right, we are going back to the triangle. This is our triangle here. All right, so cos theta, remember the ratio of cos, guys. We talked about this from this soccer trolley, this one. So as you can see, cos is adjacent over hypotenuse. So that means cos theta is going to be adjacent over the hypotenuse. So you just substitute because the triangle is now there. So according to your triangle, theta here, this is your opposite, this is the hypotenuse, and this is the adjacent. And also take note, guys, the hypotenuse is always a positive. It does not have a negative, even if it is in this negative side. This hypotenuse is always a positive. It's a resultant. All right. So according to theta, we say this is our adjacent, this is our hypotenuse. So adjacent is -4. Our hypotenuse is 5. So our answer in this case for cos theta is going to be adjacent -4 over hypotenuse, which is +5. All right. Then B, we are given to find tan theta. All right, this is what we have here on B, tan theta. So where are we going to have our tan theta from? This one. Still on our triangle, this is your triangle here, this is your theta, and tan, that's opposite over adjacent. So which means this tan theta is going to be opposite over adjacent. All right, let's just fill in. According to this theta, this is your opposite here, opposite. So this is your opposite, -3 over the adjacent. Your adjacent is this one, AA adjacent -4. So we shall have -3 over -4. But we can't leave a negative, guys. We can just cancel this. It's going to give us 3 over 4 like that. So this is going to be our value for tan theta. So as you can see, guys, it's very much important to understand the idea of the quadrants there. All right, let's see the item C, where we are given to find sec theta. That was our item C there. All right, so where are we going to have our sec theta from? This is a ratio that you're supposed to know where it was taken from. Where did we actually had this trig of sec theta from? Remember, sec is equivalent to 1 over cos theta. That is sec theta. If it is cosec, it's 1 over sine theta, but sec 1 over cos. So if sec is 1 over cos, therefore I'm going to take this because I calculated a cos before. This was our cos theta, which was -4 over 5. So if our cos theta is -4 over 5 like this, therefore I'm going to substitute here because already I have the value of cos. So it is going to be 1 over, I substitute the value of -4 over 5 like this, -4 over 5. So that's it. So they, even if you use a calculator there's nothing wrong because it's the same thing. You can know this, that you simply invert all. So using a calculator or just evaluating direct does not have any difference in this case, okay, because you can actually see that it's 1 over, and whenever you are given 1 over, you invert this fraction. So it's going to be -5 over 4. You just invert. So this is going to be your sec theta. So sec, it's 1 over cos. So the moment you have 1 over cos, you're done. You substitute your cos. So like I said, even your calculator at that stage, if you use it, there is no effect at all. So you must be careful about that one again. Then we have got D, which is cos theta minus cosec theta. All right, let's just write it down so that we can talk about it. At least if we have it written down. This is our D here, where we are given cos theta minus cosec theta. All right, just like what we did on this question, where we had to change sec to something that we are used to, which is cos. That's the same thing that you're supposed to do also on this cosec. Cosec, we know that it's 1 over sine. So this one is going to be cos theta minus 1 over sine theta. from cosec. So now that means I can substitute these values. So just like what we did, we had the value of what? Of cos. So just substituting cos was minus 4 over 5. So just substituting minus 4 over 5 in place of cos. We put minus 4 over 5 minus 1 over now sine theta. All right. So sine theta is the one that we were given. So this one is just decomposed already. This is what we were given already, sine theta, which was minus 3 over 5. So I'm just going to substitute this value that I was given before. Okay, so let's just substitute minus 3 over 5 like this. This is what you're going to have. So the question is, how are we going to simplify such type of an expression, this number or term that we are given? All right, let's just leave this part as it is, minus 4 over 5. We've got a minus, and the minus definitely is going to give us a plus. Then remember what I said, guys, whenever you're given 1 over, you simply invert these two. So it's going to be 5 over 3. So you're going to add minus 4 over 5 plus 5 over 3. So this is the part that I said, even at this stage, once you're at this stage, there's no effect even of using a calculator there or adding the numbers direct. So you can just use your calculator direct in this case, or you can add the numbers depending with what is good for you. But in exam, guys, do not waste much time. Just write your answer there. So if you add this, you're going to obtain 3 over 13, not 3, but 13 over 15. So these are the typical questions that they can give you. So sometimes you can be given maybe as a decimal, you're given maybe tan theta is equal to 0.2. What you just need to try this as a fraction. Okay, tan theta is equal to 0.2 as a fraction. Let's see if this is going to be clear. Yeah, let's just put it here. 0.2 as a fraction is 1 over 5. So as you can see, the moment you have a fraction 1 over 5, you can apply the ratio tan is opposite over adjacent. Then you draw your triangle depending with the quadrant. So this part is the one that is important here, to know your quadrant. Each and every quadrant is going to be indicated with a certain interval, each and every quadrant. And each and every quadrant has a triangle like this. So this is how you draw each triangle in the quadrant. If it is in the second quadrant, which means your triangle is going to be like this. If it was in the fourth quadrant, which means your triangle is going to be like this. If it is in the first quadrant, your triangle is going to be like this, where you have to calculate the missing side using what? Pythagoras theorem. So always you shall apply, use Pythagoras theorem to calculate the third side. So that is the condition there. You have to calculate the third side so that you can apply the triangle to calculate the other ratios. So that's it, guys, for Mason African Motives, working on mathematics N2. We're still on daily topics that we shall be working on. So more questions to come and more revisions to come till we meet again.